Hello, and this is our last video on polar coordinates. For the maths we're talking about today, the fourth type of question, equations of the tangents parallel and perpendicular to the initial line. Okay, so you need to be able to find, I've copied this from the book, the textbook. Find the tangents to, by the way, this is only in EDEXCEL, it's not in MEI. So need to find out the tangent polar curves parallel to perpendicular line. So to find tangent parallel to initial line, you set dy over d theta equals 0. And to find tangent perpendicular to initial line, you set dx over d theta equals 0. I've seen in the past, not many times, but sometimes I've seen people forgetting that which one we need to put equal to 0. So I just asked you to memorize this way. In a normal maths question, if you have to work out the tangent parallel to x-axis, which is the turning point in the normal calculus, you do dy over dx equals 0. So just remember that dy is in the top. So for any parallel to initial line, dy over d theta equals 0. So we're going to be doing question number 5 and question 7 of the EDEXCEL textbook. And so if you can you just have a look at that question, please? This is that question. It's a 6-mark question. Find the equation of the tangent. So just have a look at it. So I will pause the recording till then, so that video doesn't get long. Okay, so we're going to pause the recording. Okay, the question is find the equation of the tangents to this curve that are perpendicular to initial line. So guys, quickly now that you know how do we sketch the curves, let's see if you can quickly sketch this curve, if you can. Let's say this is the initial line. That's 0. When theta equals 0, I got r equals 2 plus 1, 3. So that's 3. Let's find this 1, 2, and 3. Okay, that's the first point. I'm just theta equals pi by 2. Cos pi by 2 is 0, so r will be equal to 0. So that'll be 1, 2. R will be equal to 2, sorry. It's 2 plus 0 is 2. Okay, and when theta is equal to pi, cos theta is equal to minus 1, so that's 1. Okay, so I'm looking at something like this, coming back there, and I'm pretty sure it's symmetrical curve. And let me quickly check if this is P is equal to 2 and Q is equal to 1. So P is equal to 2Q. That means there's no dimple. Okay, this is our revision of the previous things we've done before. So this is what it is now. Guys, what we need to do now, we're going to work out, not the area this time, we're going to work out the equation of the tangent, which is perpendicular to the principal axis. So I'm going to have 1 over here. I'm going to have 1 over here. Right, so I need to work out equation of these lines, guys. So I know, let's call this AB and CD. So for AB, I know that theta is equal to 0. And for CD, I know that theta is equal to pi. Obviously, I haven't drawn this properly. That's okay. Right, so now we're going to be looking to work out the equations of this line. Generally, polar coordinate questions, guys, you'll expect to write equation of the line in polar equation, but sometimes it's easier to do the Cartesian, and we can obviously transform from there later. Okay, so this is not the tangent of the turning point like we do in the normal maths. This is not dy on the top. This will be then dx over d theta is equal to 0. But guys, let's try and work out dx over d theta. X is r cos theta. We learned that from the first video. Okay, for taking from there now. So x equals r cos theta, and that which is r is this. So this is 2 plus cos theta times by cos theta. That gives me 2 cos theta plus cos square theta. Right, so this is the x here. I need to differentiate that. So d theta of 2 cos theta plus cos square theta. Okay, and guys, differentiation is a straight process. We differentiate both of them separately. That give you minus 2 sine theta, because you know that differentiation of cos theta is equal to minus sine theta. All right, then from here to this one, I'll use this as a normal thing there, guys. So this will be plus 2 cos theta, that's the power rule, and then times it by differentiation of cos theta using chain rule, that gives you minus sine theta. So what do I get, people? I get here minus 2 sine theta and minus 2 sine theta, and I think I'm getting minus 2 cos theta sine theta as well. Okay, so we're going to be putting this equal to 0. Equals 0, like I said, so this is minus 2 sine theta common. So I get 1 plus cos theta equals 0. So sine theta is equal to 0 and cos theta is equal to minus 1. And guys, that gives me theta equals 0 and theta equals pi. Theta equals 2 pi. Okay, and here I get theta equals pi. Okay, so these are the two values we're looking for, and we did get these two values by looking at our observation as well. So that proves that this is right. So guys, all we need to do now, we need to work out the equations of these two lines. Okay, so I'll give you a chance to work out the Cartesian equation if you can, then we can work out the polar equations as well. For AB, guys, Cartesian is, because if we take this as x, so this is x is passing through 3, x equals 3, and here x will be equal to minus 1. Let's see how do we change this into polar equations now. So x in the polar is r cos theta is equal to 3. So r equals 3 over cos theta. So r equals 3 sec theta. That's the polar equation of AB. And for CD, r cos theta is equal to minus 1. Okay, so r is equal to minus 1 over cos theta. So r equals to minus sec theta. So guys, these are the two equations. Hope they're right. You can check the answers in the back of the book. Okay, these are the two equations of the tangents to this polar curve, which is perpendicular to tangents perpendicular to the initial line. Okay, move on to the next question, which is question number 7 we picked up. So this is question number 7, as you can see on the slide. And have a look at this question. Write that down into your paper or book, and we work on it together. All right, guys, the question is r equals 1 plus 3 cos theta, and theta lies between 0 and pi by 2. And we're going to work out the tangents to C at a point A, which is parallel to the initial line this time. So parallel to initial line means it's horizontal tangents. That will be dy over d theta. Relate to the normal calculus you've done, okay, for turning points. We're going to work out the exact length of OA. So let's see, guys. I'll give you a chance again. Can you please try and see if you can sketch the curve? You don't have to. Let's see if you can sketch the curve. All right, guys. So they asked me to curve only between 0 and pi by 2. So this is 4 when theta equals 0. This is 1 when, so I think the curve is going to be something like this, okay? That's the shape I'm looking to do. But interestingly, I would like you to see if you can draw this curve between 0 and 2 pi. See how do you work that out? Give it a try. Right, so let's use the calculator. 1 plus 3 cos theta, execute, and that's the curve. I would like you to pay attention and explain to me what's the reason for this little loop inside it. Okay, the curve, can you see it just come like this? And then what's the little reason for this loop like this? Okay, have a look, pay attention, and let's see if we can discuss. Even though this is not part of the question we're doing, but still it's good to see, you know, sketching curves as well. Let me try if I can explain this, people. Listen carefully. So what happens when theta goes to pi? theta goes to pi, cos pi is -1. So 1 take negative is -1. So guys, that's why -1, obviously EDEXCEL doesn't ask you to do it. That's why we do, -1 can't do this. What do we do? If you remember my video, we go in the opposite direction. So -1 comes here. Okay, so it needs to do something to come back there, guys. Okay, and then coming back, that's why there's a loop inside there, and the curve will be like something like this. Okay. And obviously you don't need, because EDEXCEL doesn't want you to do negative curves. So we're only looking at this, guys. We want tangents parallel to initial line. What does that mean, guys? dy over d theta is equal to 0. Y equals r sine theta. So y is equal to sine theta plus 3 sine theta cos theta. I've multiplied this by sine theta. So I want to be differentiating that with respect to theta. And what it is, this is cos theta. And guys, this is, you can use product rule there as well. Okay, you can use trigonometric identity as well. That gives me 3 sine theta times minus sine theta. And then it gives me plus 3 cos theta times 3 cos theta. This is cos theta minus 3 sine square theta plus 3 cos square theta. Simplifying, knowing your trigonometry, guys, this is cos square theta minus sine square theta. That gives you cos theta plus this is what? This is cos 2a. That is 3 cos 2 theta. Right, so I've got this as my differentiation. I have to put this equal to 0. And let's see if you can solve this equation, people. So you need to learn the trigonometric identities of cos 2 theta. This is cos theta plus 3 times. What will that be, guys? Cos 2 theta is cos square theta minus sine square theta. I want to change, so -1. This is 2 cos square theta minus 1 is equal to 0. That gives me 6 cos square theta plus cos theta minus 3 equals 0. I need to solve this quadratic to get the two answers. Okay, can you do that for me, guys, using calculator? So these are the two values we get, and we have to reject this because theta was meant to be between 0 and pi by 2, and cos theta is positive in first quadrant, so we only take this value. Right, so this is cos theta. Right, that's the answer to cos theta, and we have to work out what? We have to work out the point first, A, and not the equation of tangent. It says we want to work out the point where this tangent meets this curve. All right, so we need to work out the distance from pole to A. That means actually we need to work out the value of R at this point, and R is 1 plus 3 cos theta, and I know at point A cos theta is equal to this. I'm going to substitute that into here. So R equals 1 plus 3 times minus 1 plus root 73 over 12. Okay, you can simplify this, and that should be the answer of the length of the distance between pole and the point A, or just R in that case. Well, that's your question. Move on to do another question now. Right, so this is a question I picked up from June 2013. It's a reserved paper, should be a bracket instead of 9. That's question 8. And it's a mixture of the couple of skills we've learned today, guys. So have a look at this question, draw this diagram in your book, and then we work from it together. Okay, we need to actually work this question. It's a 13-mark question, so we should be able to see what this is. Okay, I have drawn that question in my paper as well. Can you pause it and draw this into your paper? All right, guys, in part A of the question, you've been asked to work out the area enclosed by the curve. Okay, so the curve has two major petals which are repeated. So if I work out the area of one of them, I should be able to work out the area of both because they'll be symmetrical. Guys, can you see clearly? This first part of the curve is between theta equals pi by 4 to theta equals minus pi by 4. So if I find area of this petal, I'll double it to get area between these two, theta equals minus 3 pi by 4 and pi by 4 as well. So guys, using the same formula, by area equals half r squared d theta. Let's try and work it out. I'm going to pause it. You're going to pause the video, and then we'll work it together. All right, guys, so r equals 3 cos 2 theta to the power half. So square it, it gives me 9 cos 2 theta. So area is half 9 cos 2 theta and between minus pi by 4 to pi by 4. Remember, I'm just trying to work out this one petal there. I'll double it later on. Okay. So integration should be straightforward. So 9 over 2, I'm taking this 9 out. Then integration would be sine 2 theta over 2. Remember the chain rule? Then we put minus pi by 4 and pi by 4 over there. So that gives me 9 over 4. Then sine 2, this is sine pi by 2. Then take away sine minus pi by 2. Hope I've done this right. 2 times minus pi by 4 minus pi by 2. Okay, put the values in, see what you get in there. This area of one of the petals is 9 over 2. So the total area enclosed by the curve would be 9 over 2 times by 2, and that is 9 square units. Okay, so this is the first part, which was, I don't know how many marks, 3 or 4 marks we have looked. Now we look at what do we do in the second part. Because the second part, they ask you to find area of the outside there. So what are we looking to, people, in this case is we need to work out the area of rectangle, then take away that area you just worked it out. So that's a target. Think about it. How do we work out area of the rectangle? As we can see, to work out area of rectangle, I need this length and this length. Okay, and I can see this SR is rather simple because as theta is equal to 0, that means this point. Okay, our R would be 3 times cos 0 to the power half, and cos 0 is 1, so it's 3. That means this length is 3, so guys, SR would be 6. Right, so for a 9-mark question, majority of the marks are now going to be given to me. How do I work out the length of RQ? Okay, or length of SP. So guys, give it a go, have a look, think, pause, then we discuss this in about 30 seconds. As you can see, guys, this is a clever question now. What you need to work out is this length. Okay, so if you can work out this length or height, okay, and to double it, that would be that length. Okay, so being symmetrical here. Very important, if I somehow can work out this R and this theta, and this would be R sine theta. Hope you understand this, people. Very important. Now, to work out this R, people, I need to work out that theta because I'll put that theta into here. So guys, this is the point at which the tangent is parallel to the initial line. So what are the conditions for tangents parallel to initial line? So tangents parallel to initial line. I did say you relate that to turning points in normal calculus. This will be dy over d theta is equal to 0. And y equals what? R sine theta. So that will be, R is that. So this is 3 sine theta. I'm just writing first because the bracket entire cos to the power half. So as I'll be differentiating this now and equating that to 0. So how do I differentiate this? I will differentiate this by taking product tool u and v. So I'll give you a chance, give it a try, and then I will just shorten the length of the video. Step by step, take this as u, take this as v, u, v here, u dash, v dash here. So we write down the whole thing together, which is uv dash plus vu dash, and put it equal to 0. So let's write it down there, guys. Uv dash plus vu dash, and put that equal to 0. Then we try and solve that to work with value of theta. This is what I've got. So guys, I'm going to do what I'm going to be taking, because this term is coming out as negative. So I'll be solving this, divide them by 3 because both terms have 3 common. So I get, I take this term to the other side and write down again. Guys, do that, please. Let's see if we can work out the answer there. I did make a copying mistake. This was 2 theta. So guys, we cross this bit out. We start again. I've done u, v, u dash, v dash. So this is where we reach in this stage. Now let's try and simplify this from here. This is 2 sine square theta over cos 2 theta to the power half is equal to cos 2 theta to the power half. Okay, take this to the other side. So 2 sine square theta is equal to cos 2 theta. Okay, because power half and half will times to give you add, and then okay, because 2 theta. Now we're going to try and solve this equation, right? And I'll probably try and change cos 2 theta into sine squared form. So cos 2 theta is 1 minus 2 sine squared theta. So I get 4 sine squared theta minus 1 equals 0. So sine squared theta equals 1/4. So sine theta equals plus minus 1 over 2. And we see what values of theta, guys. So theta would be pi by 6. And as we were looking for this theta is pi by 6 at this point, or minus pi by 6 at that point. So guys, what I'm trying to work out, this length, so which is theta is equal to pi by 6. And r is this. So this length is r sine theta. So that will be 3 cos 2 theta. That was 2 theta. That's a mistake. That's where we all started from. Okay. To the power half, and then sine theta, and theta is equal to pi by 6. So guys, what does that give me? Right, so this is when you put theta equals pi over 6, I get these values. You can check that later. This is my length, guys, that one from here to here. So what's my total length of PS then? So PS is equal to double of that, 3√2 over 2. Now guys, so if you remember, we worked out our somewhere, yep, that's it. SR is equal to 6. So RQ of PS is equal to 3√2. So area of the rectangle area is 3√2 over 2 times by 6. That gives you 9√2. So guys, the shaded area then, shaded area is 9√2 the rectangles. Take away 9 the area of the curve, and that's the answer. Right, just 9 mark questions, a lot of 9s coming in. Guys, this is it. This is our last video on polar coordinate. Hope it's helpful, and we'll come back with another videos, another topic. Thank you very much, everyone. Bye.